Thank you very much for the opportunity to be here today. I hope to share a few things that are happening within the Open Compute project and share some initiatives that may add value to your communities locally. I'll cover some background around what is Open Compute, and then I'll cover 2 or 3 of the key initiatives specific to Telco and highlight just a few of the other programs and projects that are happening that show the massive growth in the data center infrastructure that we have today. A bit of background around the Open Compute OCP. The OCP was started in 2011 by Facebook or Meta at the time, and they were outgrowing their infrastructure. And so they decided to design their own servers, their own hardware, even their own data centers. And at that time, working directly with a manufacturer to design their own servers was not new or different. But what is new and different back then is they open sourced those designs. So they open sourced it to a community around their servers, networking, storage, and data center designs to increase the pace of innovation. So now 10 plus years later, we are at over 300 companies, and our goal is really to take that hyperscale-led innovation between some of our board members and through our projects, drive shared innovation, shared specification, and best practices. The growth within OCP, as I'd mentioned, we're over 300 companies now, over 150 projects and work streams. So we are an open source hardware and data center foundation. And the recent analyst numbers coming out this year have indicated that we are impacting the market with over $34 billion worth of revenue driven of OCP designs through our OCP members. And I'll get into some of those examples in just a minute. Our board of directors are names that you probably know. There are 4 key companies at the top: Meta, Microsoft, Google, and Intel. And our advisory board are the 7 companies then below that. Some of the largest IT companies in the world, providing some of the thought leadership in how to take this large organization forward. Our projects, well over 100 work streams, but we really focus on these top 12, and then there are sub-projects underneath it. So you'll see everything from networking, rack and power, server, cooling environments, data center facilities, telecom, and security. So I'll focus on just a couple of these today, but a lot of these have multiple hundreds of people working within that. Across our organization, we have over 5,000 hardware engineers that are volunteers working within these projects. So they're run by volunteers, led by volunteers of those companies that I shared prior, of those 300 companies, and then they drive specifications to the larger community and the market. One of the areas I wanted to share with you is one of our strategic initiatives that's taking place currently, and it's a contribution from Meta that took place last year, and it's for a truly open radio unit. The nickname of that, or the code name, was Evenstar. So Meta created a specification around the open radio unit, and it was really designed for 4G and 5G networks, aligning with 3GPP and the O-RAN specifications. The goal for Meta's specification around this was to drive down the total cost of ownership and the CapEx and the OpEx around the RAN, being the most expensive area of the entire network. Their goal was to really drive that cost and those efficiencies out of that radio unit and allow greater flexibility and make a radio unit that was accessible for all markets and all kinds of people. So this has specific market capabilities, and it was transitioned to OCP the end of last year, and we're just now building the community around that. So this is the initial base specification and what was contributed by Meta. And our current project is taking this base specification, determining where the gaps are and how we can make the contribution better and the specification better, and also then developing a family of SKUs. So it won't just be this one radio box for this one use case. It will be a family of radio unit SKUs for different workloads, private 5G, emerging markets, a lot of different ideas that the community can drive. So we as OCP will not dictate what type of device will be, the community. So if you're a telecom operator and you have feedback to the community about what you would like to see in this radio unit, you can get involved in the project, share this feedback to the project leaders as the community develops. Currently, this project is being led by Bell Canada and a couple of other strong volunteer leaders. Those calls happen monthly, and I encourage you to get involved, and I'll share with you some of those resources on how to get involved. We think that this is a very significant market. The tier 1 CSPs will fuel the demand over the next 6 years, but you'll see down here where we think the Latin American or CALA market and the early adopters of a radio unit like that might participate. We see a few of the drivers around Europe and in Asia taking up the ORU market, but we really believe that this open radio unit can have a very nice market potential and a lot of use cases in Latin America. If you go to opencompute.org, you can go down to strategic initiatives and you will see the Evenstar Open Radio Unit. And within that, you can subscribe to the mailing list and join the monthly calls or listen to the monthly calls. And all of these links are provided post the event in the deck that I am presenting. The team at WhiteStack will make sure that you get this deck with these links. So we encourage you to join and participate. Another key area that I wanted to share with you is OCP driving the supply chain. So we will take community-based specifications similar to the one that I just shared, match it with the market opportunity to determine what makes sense for the mass market in the community. And through OCP solution providers, those companies that are focused on OCP solutions, we will take those to market along with alliances and through various different ways, through workshops and through our marketplace and through alliances and experience centers to drive a multi-vendor supply chain. So having one company with multiple vendors driving off of the same specification. A few examples of this that we've had success at is on the left-hand side, you will see the Open Edge servers, which is a mobile edge computing platform that is very highly adopted worldwide. Very large OEMs use this platform, as well as some direct manufacturers have taken this platform. We have Open Edge CUs and DUs. Our networking for Telco is quite strong, with dozens of networking switches that have been opened up and that have been through either ONF or the Telecom Infrastructure Project as well. And on the right-hand side is one of our latest contributions by AWS, and that is for an open enterprise gateway that they will be using in their retail stores as well, that we've combined, that we've worked with Linux, the Linux Foundation on. So OCP owning the hardware ecosystem, and then the software and the testing and validation happening through places like the ORAN Alliance, the Linux Foundation, and ONF. I wanted to share a roadmap of one of our members called MyTech. They are a very large manufacturer out of Taiwan, and they shared this roadmap a few months ago at our regional summit. And it's really around a modular DRAN and CRAN, DU and CU offering. Their view is that it will have to be purpose-built at the cell site. So I wanted to share with you some of the examples here. On the left-hand column, you can see what their current offering is and what will need to be moving forward. And this is their latest offerings that should be in market here in Q4 or early Q1. But with the AI workloads increasing, a lot of this computing power will need to increase at the edge and on the CU and the DU. So this is their DU roadmap that is coming through OCP in the coming months. Another thing that you will hear about within OCP is a modular hardware solution. So what we call the data center modular hardware system allows you some reusability, some replaceability, and flexibility and modularity when it comes to a server design. So instead of removing the entire server components, you can replace different components, whether it be memory or compute storage, without replacing the entire motherboard, as an example. So everything is going to become modularized, and this is an example of what is modularized in their new Edge DU that will be coming through OCP. So a couple key things as well. So one is the Open Radio unit. The second is around the Open Edge platform that we have for CU and DU, and a glimpse into the roadmap of what some of our members are looking at for modular hardware designs at the edge moving forward. I wanted to also touch on rack and power and cooling. It seems to be one of the largest topics that we have moving forward, is how are we going to cool this infrastructure at the edge, and how are we going to get power to the edge? And this is one area that we are spending a great deal of time on with new rack designs that have been driven by the community across these three companies. And in the middle, I wanted to highlight some of our sustainability work as well. This is a wooden data center rack, prototype out of Germany, and they are building wooden components for sustainability reasons. And so this is the latest OCP version in wood being driven out of Germany. So as you can see, within the community, we are covering both the component level all the way up to the rack and power to figure out how are we going to power these AI systems or these AI workloads, or increasing compute workloads at the edge. On the cooling environments, these are our sub-projects around cold plates, immersion, rear door heat exchange, focusing on heat reuse and how we manage the hardware for liquid cooling. And on the right, you will see some of the key members that are participating in this work stream. So you'll see cross collaboration between fluid manufacturers, petrochemical companies, as well as component companies such as NVIDIA, Intel, and system level providers such as Dell and Vertiv. Data center, all of this hardware that's being created and agreed upon within the community needs a solid co-location or a data center facility that understands this hardware, that we can roll it through its scale, and is optimized for this new way of doing hardware. And so this is another area where we've spent a great deal of time co-authoring guidelines for data center colo providers and telecom operators to be able to take our guidelines and showcase exactly what is needed for white space, for physical build outs, for mechanical, for loading docks, elevator heights, and ramp heights, all throughout the data center that is needed for open hardware. And this checklist or guideline was co-created by Google. So it's really essentially one of their checklists that they help provide to colo providers to help pre-select and to ensure that their facilities are up to standards for co-location deployments for hyperscale equipment. And it's something that we've found that our telecom operators really find value. They don't take the entire checklist, but they take the parts that are most relevant for their industry. And again, that goes back to the very first point I made, which is taking hyperscale innovation to the rest of the market. So taking best practices of what some of these companies do and applying it to your local environment. And I will leave you with this. It would be great to have you all join the OCP, at least to listen to some of the project calls, attend some of the events. It does not cost anything to listen and to attend these events. Everything that we do is in the open to download specifications. We have our global summit coming up in California, but we would welcome any of your team to join. And hopefully you found value in this short and brief presentation around the Open Compute Project and what we're doing around telecom and the entire data center infrastructure. So thanks again to the team at Whitestack for allowing me to share a few ideas today. Thank you very much.